folks, and we're live. Welcome. My name is Ian Creek, and this is a test stream for Mount Bennett Observatory doing a live imaging session. So I've got my telescope set up outside now, and I've got it connected to my desktop via the internet or via the network. And what you're seeing on the screen now is the interface that I'm using to capture sort of live images of the night sky. So while we wait for people to join, I'll do a proper explanation in a little while. But in the meantime, you can see we've got the Trifid Nebula on screen. So this is the image, or this is the object that was used in the header for the first night of the observatory event. This is something that was captured right now, and it's currently still being captured. So the data is being added to this as we watch. We've got some people joining. Wonderful. Hello, Arishana, Kate, nice to see you all. Glad you could join us. I will try and keep an eye on the comments to see if there's any questions. So please do ask questions as you go. We'll also have another member of the outreach team joining us in here to help with answering questions about MBO, moderating to make sure there's no spam. Hopefully we won't have any issues with the scams that we have in the live event, because this is completely unplanned. They've gone through, they don't know what's happening. So I've got myself a cup of tea. So I'm sitting inside nice and warm in a t-shirt while it's cold outside, and my telescope is imaging right now. So let's, oh wow, there's lots of comments coming through. Hi folks, nice of you to join us. Now I've just noticed that I can't see new messages without scrolling down. It doesn't scroll automatically. So, okay, I just heard that we've got an issue with the volume. Let me see if I can fix that. I'll turn off my microphone first of all. How does that sound? Is that a bit better, folks? It's sounding a little bit better in my headphones too, so that's good. Just scrolling through to make sure there's nothing else. Okay, lots of issues with the sound. Hopefully this has fixed it. Okay, is that any better, folks? Yeah, give us a little bit of feedback. Okay, we're still saying it's difficult to hear, but that might be a little bit of a lag in the stream. So, okay, I've got my volume on my OBS turned up. So, I see what's going on. We've got it coming from the wrong source. Hold on. Testing 1, 2. Oh, that's better. I think I've overdone it now. Testing 1, 2. Testing, 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 testing. Okay, that looks about right. Maybe a bit too loud. Okay, is that better, folks? Tell me if that's too loud. Have we still got live video going on? Because my preview has gone blank. Okay, we're back. We're just fine, but sound is very quiet. Okay, much better. Okay, that's fantastic. I think I had the audio input in OBS, the streaming software I'm using. I had that set to the wrong microphone, so that would be why. Is it too loud now? I just don't want to blow your ears out. Okay, we're getting mixed comments now on the sound. Great volume now, excellent. I see Heike is in the chat answering questions for me as well. That's fantastic, thank you. All right, so now that we've got the volume sorted out and you can all see the screen okay, I'll just go through a little bit of an intro. We are doing a test here. This is just an impromptu thing. This morning I saw the sky was clear. I checked the forecast. The clouds were supposed to be good tonight, so I thought, why not give it a go? A lot of people were hoping that our last live stream, the night at the observatory, would actually have live imaging of the night sky or live sky stargazing, which would have been great. We'd have loved to have done that. But there are a couple of reasons we didn't. First, it was cloudy, which is always a big problem. And second, we were just doing our very first stream. So we wanted to get a handle on how to run a stream, all the technical side, getting the flow working right. We had a whole bunch of people working together to make it all happen, so we had to coordinate. So we wanted to just have a stream where we didn't have to worry about anything that was live and unpredictable interfering with that. We didn't want to have something all set up to go and then the clouds came through. So our first stream was just a simple thing, but we're hoping in the future that if the sky is clear, then I can set up my scope, or other members might be able to set up their scopes,
and do some demonstration of live imaging and live viewing. So that's what we're testing for here. Of course, this is something that's dependent on the weather. So if we have a live session planned, but it's cloudy that particular night, then we'll need to have some content that we can drop in and use instead. So this is all part of the test, and it's great to see lots of comments coming through. It's going to be really hard to answer questions because there's so many comments, which is fantastic. We've got 324 people watching. That's brilliant. All right, so I've just got the telescope currently pointing at M20, the Trifid Nebula, which is the object that I used in the image for the header for the Night at the Observatory event. I had it set up here just to test, make sure everything was working, but I'm going to show you a little bit about how I go around finding objects, and we'll do a live image of that so you can see how it develops over time. If you're looking at this image now, you can see it's pretty clean, not much noise, there's a lot of detail, you can see a lot of nebulosity there, which is great. But let's go and pick a different target. So I'm going to go to a Planisphere or Planetarium software here. It's got the whole night sky in there. So I zoom out, you can see that. It's an image or a representation of the Milky Way going across there. So I'm going to go to the M8 Nebula, which is also known as the Lagoon Nebula. I like to call it the Mate Nebula, M8, mate, get it? Anyway, it's really close to the Trifid, so we should be able to slew right over there. You can see this little preview here. This is where the computer believes my telescope is currently pointing. It's pretty accurate. I've tried to configure that already, although it doesn't seem to be going right to the middle. Oh, there we go. It's just a bit of lag there. So if we go back over to the image view, we'll turn off the live stack. Actually, we'll turn it back on again so we can clear it. Oh, there you go. You can see this is what it looks like if it's imaging while the telescope is slewing. How long is this? Is just a question I just asked. No idea until I get bored of it, basically. Might go for half an hour or an hour, even longer. Depends on how much fun I'm having or if the clouds stay or go. Well, if the clouds don't come in. Currently there aren't any clouds, which is great. So what I'm going to do is I'm going to, first of all, I was going to save the settings I've got now, because I set up a couple of different presets for the settings, and we'll go over to the Finding Target preset, which means it goes much faster. So that means I can get a preview much more quickly of where I'm pointing to make sure that I'm pointing in the right spot. Okay, and I can see now that this is slowly panning. That means that it's not tracking currently. So I need to go over and make sure. Okay, it says it's tracking. Why is it panning like that? All right, let's just make sure we've got the telescope connected. It says it's tracking. Okay, so what have we got here? Now, this is one of the things about imaging, is that there is always technical issues, always things that cause problems. There's more time spent troubleshooting than there ever is actually imaging, or at least it feels that way sometimes. So I'm going to just play around with this and see if I can get it to behave itself. Okay, and it's not responding at all. Interesting. All right, so let's disconnect the telescope from the Planetarium software. So we'll disconnect it. Give it a second. Reconnect it. And see if it starts behaving. So turn on tracking. And let's see if it now knows where it's pointing, because it's disappeared off the screen here. Let's check the camera. Is it still panning? No, it's stopped. Okay, that means the tracking is now working, which is great. So where are we? Track telescope, is that it? Oh, okay, thanks for pointing at the South Celestial Pole. Let me just check my settings. You probably can't see the window that I'm looking at the moment. Yeah, it sent it back to its home position. Oh, actually you can. I can see on the stream it's popped up. So the telescope has a home position, a safe position, which is pointing straight to the South Celestial Pole. And if anything goes wrong, it zooms straight over there to be sure. So I'm going to take control of this again, and we'll go back over to M8. We'll right click on that and tell the telescope to slew over there. So if we zoom out, you should be able to see the telescope here. There it goes. It's coming into the screen. It'll move over to M8. Okay, we've had a question asking for a planet. That's a great suggestion. I will try to get to that soon. There are different kind of objects to image than nebulae. So they're different settings, different challenges. So we'll do this nebula first, and then we'll see if we can have a look at Jupiter. All right, so we should be centered on that object now. Let's zoom back out to full view. Let's make a little bit longer exposure times. You know what? I think this object may have already set behind my local horizon. I have a lot of trees and a couple of close buildings nearby here, and that means I have limited options or limited parts of the sky that I can image, and I do know that this object was getting close to the horizon. So let's try a nearby one that might be a little bit further up. I use another piece of software which is on my desktop, which you probably won't see, which I can, yeah, you can't see that, but I can use it to, I've got a fake horizon or a simulated horizon showing what is up around my area. Okay, it should be up. Interesting. Thank you for your patience, folks. Again, this is what imaging is often like. Things don't go quite how you expect them to. All right, so we're not getting any stars at all. So I'm going to point to another part of the sky that I know is going to be up. So that will be something I can be sure of. And this is also why we do tests. So I'll be working to improve this for the next time when we go live. I wonder, maybe the Large Magellanic Cloud, is the Tarantula up? So the Tarantula Nebula is a very, very bright nebula in a nearby dwarf galaxy. And that is it there. So let's try sending the telescope over there and see if that's above the horizon. So we'll slew to that. So we can watch the telescope's indicator moving across the sky. Where is it? There it is. So here it comes. Carla, yeah, it is interesting to see what happens behind the scenes. The photos that come up that we publish, that we put in the slideshow, in the live show, for example, they're the end results of many hours of work, of troubleshooting, of learning techniques and software and making things work. This is the hard behind the scenes process of getting that information, of getting those photos. All right, so it's not on an object right away, which is not surprising because it's the telescope. The way that I'm controlling the telescope at the moment now is best suited for live imaging rather than setting things up and doing one long session for a night. And the technique to find objects is a little bit more, I wouldn't say random, but it's less refined, less accurate. So it's a little bit of a guessing game. So what I'm doing here is I'm telling the telescope to go around in small, ever-increasing circles around the position I was at, and I'm watching the screen at the same time to see if I can see the nebula jump in. If this doesn't work though, I do have some other options I can do. I might go back to where we were because the telescope knew where that was and look for an object nearby and then try to update the pointing model with that so the telescope knows where it's pointing. Just to give you an idea of why this is a challenge, if you go out in the night sky and you look up at the stars, you can see all the stars all overhead and you can see everything all at once. You turn your head a little bit, you can see the whole sky. But when you're looking through a telescope, it's like trying to find something by looking through the barrel of a pen. You're only looking at a very small part of the night sky, and so if you're pointing at one area and you can see through the barrel of the pen, you think, okay, that's not where I want to be. Where I do want to be? And it's really hard to find it by looking around with that really narrow field of view. All right, this is not giving me any luck at the moment, any success. So I might fall back. And you know what? Jupiter is actually kind of near. that other object, and it's really bright. So we'll give that a try. Okay, I'm just randomly checking over at the questions as they scroll past. So I'll pick out some occasionally, but I'll probably miss some people. Tanya asks how fast the telescope track. It's sort of hard to say. It could go from one side of the sky to the other side of the sky in about a minute. And it could go from sort of, one side of the moon to the other side of the moon in just a couple of seconds or less. So it's fast, but it's not super fast. It wouldn't hurt you if you're standing in the way, but it's not like you have to wait a very long time for it. All right, so let's try slewing to Jupiter. I'm glad people are enjoying the stream and seeing the behind the scenes stuff. Even though it's not always stuff that goes smoothly, it is a sort of a look behind the curtain. And astronomy and astrophotography, it is a hobby that requires patience. Oh, it looks like I've lost my camera. Let me see if I can get that back on again. Okay, hang on. How's that? Is that better? I can't even tell anymore. Hang on. Okay, yes, it is back. Good. All right, are we pointing at Jupiter? Let's look at the camera. All right, nothing there. So let's just do that spiral search again. And if Jupiter is nearby, we won't miss it when we're panning around because it is so bright. Okay, now I'm not seeing any stars here. So why are we not seeing that? Am I pointing in the wrong spot? Okay, this is one of the pitfalls of doing it via my via internet network connection, rather than being out with the telescope. I can't just look over at it and see if it's pointed at the wrong spot in the sky. So what I might have to do is I'm just going to duck outside, out to my backyard, and I'm going to see if the telescope's actually pointing where it's supposed to. So I can confirm with my own eyes what's going on. So I'm afraid I'm going to have to leave you with a bit of dead air. But when I get back, hopefully we'll have a better idea of what's going on. So back in a moment. Need my torch. Okay, that was weird. It was pointed at the ground. I don't know why that happened. Oh, and now I'm looking at the stream, I can see from the delay, you can see the light of my torch pointing into it. So we've got stars again. That's something. All right, so now I've got to make sure the telescope knows where it's pointing. So, all right. Right ascension 13 hours, tech plus 0. That seems a bit weird. So what I might do is try disconnecting the telescope and reconnecting it, and hopefully that'll reset things. So what I did was I manually reset the telescope back to its home position. So everything should be zeroed out again. I'm glad you guys are thinking this is cool. It's a bit frustrating when things don't work out. So I'm glad you're enjoying it despite the problems we're having, or the problems I'm having. All right, well, let's see if if this has worked. So let's just make sure that the software thinks it's pointing to the South Celestial Pole. So yep, there it is. Okay, so it thinks it's pointing there. That's great. So let's go. Okay, I'm hearing messages coming through. I'm guessing that might be Hiker. So I'm going to check that in a second, but let's just center the telescope on M8 and see if that comes up. Thank you very much, Hiker. Yes, the lens cap is off. Cheeky. Alright, is the telescope moving? Yes, there it comes. Alright, let's check the camera again. That's looking better. There's a lot of stars there. That hopefully means that it's near the center of the Milky Way, which is where I know where the M8 Nebula is. Still getting some drift though, so it looks like it's not tracking. So, telescope. Ooh, has that crashed? That would explain why. Everything's going right tonight, isn't it? Alright, I'll close that and restart it. Yeah, the software, the laptop I'm running this on, there's a laptop outside connected to my telescope, and I'm connecting to that via a screen sharing app, and it's a 10-year-old laptop, so things are prone to crash. I've bought a new laptop to run this through, but there's so many little bits and pieces of software to control all the different hardware, and they all have to talk to each other, and the configuration to get them right takes forever. So I've kind of been putting things off, getting that sorted out. So, oh, is that responding again? Okay, it says they're having trouble playing the video on the stream. Can you all see me still, folks? Control-Alt-Delete on the laptop. Yes, okay, so let's kill that. Alright, so we were in SkyChart. We'll end that. And EQ Mod's not responding. Okay, EQ Mod is the software that actually drives the telescope, so it connects to all the other bits and pieces that want to tell the telescope where to go. We're getting a nice little pan here through the center of the Milky Way. You can see all those stars. You can see little bits of dark nebulae here. These are areas of the Milky Way where there's gas and dust that obstruct the light from behind. These areas are sort of like star clouds. They're parts of the Milky Way that are more dense than other parts. So even if I can't point where I want to right at this moment, we're still pointing at something pretty, but I do want to get to some specific objects. So let's try and do this again. Okay, you can still see me, fantastic. All right, so telescope, connect. Okay, it doesn't want to connect to the telescope. How about that? All right, how frustrating. Oh, and it's crashed again. Wow. All right, thank you for your patience, folks. This is why we do these tests. All right, let me kill that again. And it might be that because I've got some other software running in the background, which I use for connecting to the telescope, that might be conflicting with it. Let me just see if I can connect to it here. No, okay. And now this is crashing. All right, I might have to go out and do a hard power recycle of the telescope. Oh wait, EQ Mods popped up. Yeah, connection error. Yeah. All right, I think that might be it. I'm going to go out and reboot the telescope. Hopefully that'll fix it. And for those of you still staying around, I really appreciate it. Hopefully we can get it working and it'll be all worth it. And if all else fails, I'll just do a slideshow of my astro photos or something. So be right back. Okay, at least the telescope was pointing in the right area at that time. I think there may have been power fluctuation, maybe a loose cable or something that caused it to reset after it got there. So I need to tell it to go again from scratch. So let's kill the things that aren't responding. End that. I might end that too. Just because having extra software open is an extra thing for the 10-year-old laptop to deal with. Have we still got imagery coming through from the camera? Wrong button. But yes, we have. Okay, that's good. That's something at least. Okay, so let's connect. Come on, go green. Yay! Okay, we're green again. That's good. All right, let's try M8 again. Telescope, slew to M8. Is it moving? Yes, it says it is. All right, fingers crossed, folks. Okay, so let's look at the questions. Can you have a look at Mars? It's your favourite planet. I don't know if Mars is up yet. It might be. I'll check it out. I want to just get this pointing in the right spot first. Then we'll go to Jupiter, because I already promised that. And then we'll see if Mars is up yet. So, fingers crossed. All right, it says it's tracking. Let's go to the camera. Go away, I clicked the wrong button. Okay, the camera is live, but it's not pointing at exactly the right spot. So let's just do a quick spiral search. At least we're not getting black now like we had before. And that was really bizarre. I went outside and the telescope's pointing upside down at the ground. That's never happened before, so I'm not exactly sure what happened there. I'm fearful that there might be a loose power connection somewhere in the telescope's drive, so that while it's slewing, it resets and then restarts again, and that means it resets its home position. It thinks it's pointing back at the South Celestial Pole, and so every time I try to point it somewhere again, it does it relative to where it thinks it's pointing, not where it is pointing. Oh, there's a bit of stuff getting more dense up there. Let's see if we can find it. I shouldn't have to do this for every object, because as I find each new object, I tell the telescope that it's where it's pointing. So I update it to make sure that it's pointing, or thinks it's pointing in the right spot. So where it thinks it's pointing and where I know it's pointing coincide, and that way it gets more accurate each time I do that. All right, come on. Oh, this must be such engrossing viewing. I'm sorry, folks. All right, I'm going to do this manually for a bit, because we're getting closer to the middle of the Milky Way, which I know where that object is, or near where that object is. Oh, there's a nice little globular cluster there. See this? That's a cluster of probably tens or hundreds of thousands of stars in a tight ball that orbits the Milky Way. We're looking at it through the Milky Way in this shot. Let's keep going up that direction. And maybe we can restart our spiral search from that point. Now, as I said, normally I use a different technique to find what I'm looking for, and it's much more accurate, but it's not suitable for doing live outreach like this, because it's designed for taking long exposures of single objects throughout the night, and so it kind of makes for boring viewing. You're only getting to see, grainy black and white previews, whereas when this works, you'll be able to see high resolution color images live on the spot. So the compromise is that I can't use the really accurate pointing techniques of the other technology when I'm doing this. So for the live stream, what I might do is, if we're lucky and we get 2 nights of clear skies, I might spend the night before the live stream doing this and getting the telescope's pointing model correct, and then leaving it out overnight, and then the next day it'll hopefully be in the right spot already, because this wouldn't make for great viewing for a live stream. Alright, let me just check messages. What camera are you using? What camera am I using? Okay, sorry, Heike. I know you've had a couple of wines. Your typing's not the best. The camera. I'm using an astrophotography specific camera. And actually, while I just chat about this, I'm just going to center that that's globule cluster, and I may as well just photograph this area because it looks interesting here. So, yeah, all right. So while I'm talking, I will click on Live Stack, and what this does, it starts out looking really crappy, and it takes, actually part of the reasons why it's looking really crappy is because I'm on the finding target settings. So we'll go to the imaging settings, clear that, and start again. So now it'll take 30-second exposures and it'll update every 30 seconds with new data. And you'll see that appear in the black box there, but I'll explain that more in a second. So the camera I'm using is an astrophotography specific camera. It uses a Sony sensor, which is actually in some of their mirrorless cameras. But the reason why it's good for astrophotography is because it's got a few features built into it that are really good for night sky photos. One of them being a cooler. So when you have heat in your sensor, and sensors get hot because there's a lot of electricity passing through them, that heat can cause extra noise, extra grain in the pictures. So if you can cool down the sensor to lower temperatures, that means there's less noise. And noise is always the enemy of astrophotography because these things are so faint. You might know that when you take photos with your phone at night, things look really grainy. It's the same issue, but things are so dim in astrophotography that to brighten them up enough to see them, the noise becomes a really big problem. So we have to do lots of different things to remove that noise, and one of them is cooling the sensor. So if you look down here, you can see cooler operating at 15%, so it could go cooler than this, but it's set to -20, and it's at -20.1, so that's great. It's -20 degrees Celsius at the sensor. Okay, what's going on here? Why is it not showing anything? All right, let's just cancel that, go back to our finding settings, and is it still there? Okay, there it is. Let's try that live stack. Well, we'll go to imaging settings and we'll do a single exposure with this first and see if that, it's not updating. Okay, now it's doing a 30-second exposure. You can see the time here and the progress bar. You'll see it pop up over here. I'm not going to do stacking for this first test shot. I just want to get a shot working, then we can do the stacking. Okay, pick and volume, excellent tonight. Excellent, that's terrific, thank you. While it's doing this, I'll scroll back and see if there's any other questions. Okay, glad you're hearing loud and clear, that's great. And here it comes, and all right, it's obviously using settings for the fast view. That's why I forgot to change a couple of other settings as well. It's not just about the exposure time, so I will save that. Can I manage? Save. Will it override it? Yes, okay. Let's see if the live stack will work now. So no frames in yet, this will be the first frame. All right, so Sarah Wallace, we purchased a supporter pack. Fantastic, thank you very much. 11-year-old wants us to become members so we can come up and visit once lockdown is over. That is well worth it. You will enjoy coming up there. It's fantastic fun. Okay, what's going on here now? So, go through my settings and make sure. 30 seconds. Gain of auto. Let's turn the gain right down. Why is that overexposing so much? Is it just a histogram? There it is. It's just a histogram. Okay. I must have accidentally dragged the white level. There we go. That's looking better. All right. So we've got one frame of 30 seconds and we've just stacked a second frame. So that means now the noise is reduced. So let me zoom in on that. Let's go to 100%. So actually we'll go to 200%. It may be a bit hard to see here because the long exposure and the cooling does help reduce the noise and the grain, but there is grain in between these stars here, mostly color grain, color noise. See how it got a bit high contrast then when it added the third frame. What it does with each frame is the noise is generally random between each frame, but the stars are a constant. The signal is the same for the stars for each frame because we're following them. So when you take multiple photos and you blend them together, the stars, which are the same in every frame, add up, whereas the noise, which is random between each frame, averages out. So that means that over a longer period of time, you get higher contrast, sharper details, and you can bring up the brightness so that the fainter parts of nebulosity and such become visible. Whereas if you'd only done one exposure, then the nebulosity would be the same brightness as the noise. So by brightening the things up, you'd be brightening the noise as well. And so that nebulosity wouldn't stand out. Okay, so I wish I knew which globular cluster this was so that I could tell the telescope where it was pointing. Gail asks, do I teach astrophotography? Yes and no. At Mount Bennett Observatory, I teach astrophotography sort of informally. Anyone who brings up their camera or telescope and wants to take some shots with it, I'll help out if I'm there and if I have the time. Usually I do. I've also done a few lectures at MBO about astrophotography. Those ones I actually had recorded. I recorded them myself, in fact, and I put them on my YouTube channel. So if you go to YouTube and you search for my name, Neil Creek, Neilcreek, and the word astrophotography, you should find those tutorials there. All right, so we've got 5 shots here. It's not really changing much because these are just stars, and stars look pretty good after a few shots. It's when you have faint nebulosity that you really want to have more exposures. So let's go and see if we can find Jupiter this time. Okay. So Jupiter is an entirely different situation. Because it's so bright and it's so small, you need different settings in order to get a good image of it. So I'll talk about that once we've found Jupiter. Hopefully it will be a little bit easier than we've had so far. Okay, my stream has stopped working. I can still see the questions coming in, so I know you guys can all see it. So I'm just going to reload the page just to make sure it's still coming through for me. And I see we've got 307 viewers. That's wonderful. Thank you so much for coming, folks. All right, so go to the camera. We'll turn off the live stacking. We'll go back to the finding target settings. And there we go. Okay, so that's not Jupiter. Let us do a spiral search. While we do that, I'm going to just see what other questions there are. Okay, I actually have to hold my mouse down on the button to do the spiral search, so I can't scroll through the questions at the moment. I'll get to questions when I'm doing longer exposures. Okay, so Janelle says that the audio is out of sync. I don't really know what I can do about that, unfortunately. There's so many different steps along the way that could cause the problem. The sync of the camera to the microphone, the software to the live stream to the internet, and then onto your computer. So Oh, there's a glow. So yeah, I don't know if there's much I can do to fix that, I'm afraid. Let's see. There we go. That's Jupiter. You can tell because it's so bright. Let me just center it. And then I shall update the pointing model of the telescope so that it knows where it's pointing now. Yeah, see, that's how far off it was. And this center circle here is about the size of my camera field of view. So if we synchronize that, sync Jupiter, then that will mean hopefully that future objects that we look at will get much closer, much more quickly. All right, so because Jupiter is so bright, the opposite of nebulae, we have to change our settings to suit that. So we'll turn down the gain all the way. Gain is kind of like a volume knob on a radio or on a computer, like on a camera, it's the ISO. I'm also using a technology here called binning, where it takes every group of 3x3 pixels and combines them into one. Great for faint objects, but you lose resolution, you lose detail. So I'm going to turn that down to 1 because Jupiter is not a faint object and we want to get as much detail as possible. All right, got another message coming through from Hiker, so I just want to make sure. Okay, Hiker, you said your screen is frozen, the comments are still coming. Same thing happened to me, so just hit refresh on the screen. Actually, you probably can't see me saying that. So there you go, I've messaged you now. Okay, so, all right, sorry to keep you all waiting for Jupiter. Let's capture just the center of the frame. And this is where it gets a little tricky because we don't want to move the telescope too fast to center it. There we go, that's the right direction. Now we can see Jupiter there and 3 of its 4 moons. Maybe if I just go out a little bit, we might see the 4th one. Yes, there it is. So I can't tell you right now which moons are which. I need to look that up, which I will do. But first of all, I want to get the settings right so we can see it better. So if I drag down the shutter speed, then you can see it doesn't overexpose anymore. And now we've got some detail there. You can see the clouds. All right, so let's zoom to 100% on that. Okay, not much different. We'll zoom into 400%. Now, my telescope is optimized for nebulae, not planets. So it's great that I can see the bands of Jupiter, the cloud bands, but it's not the best equipment to be doing this sort of image. You want a telescope that's very good at imaging very small objects, high resolution, whereas most nebulae are very wide, very large scale compared to Jupiter, and you don't need to have quite as high resolution for that. In fact, the higher resolution your camera is, the more noise you'll have because the pixels, the sensor sizes are small, and bigger sensor sizes, bigger photo sites, the pixels that collect the light, they collect more light within their sort of their bucket, and that averages out the noise more. So you get better noise results with larger pixels, but that means lower resolution. And because Jupiter is so small in the sky, you really want to have high resolution for that. So nonetheless, you can see Jupiter here. It looks fantastic. The color's not quite right. It's a little bit green. Let me see if I can fix that. No, that's just an output histogram. I think I have to do a live stack for that, but I don't know if it'll do live stacking with planets. Let's just have a look. No, it won't. It needs stars to align them. So I can't really fix the color for that, but that's okay. This is capture software. You don't do our processing in this software. We capture the data in this, then we take it into other software to process it. Now, planets, again, as I said, are different than nebulae. You can see here it's sort of shimmering and wobbling and moving around and going blurrier and sharper. That's because of the atmosphere. We're looking through kilometers of atmosphere between my telescope and space, and then a long way to Jupiter, but there's no atmosphere there. That atmosphere moves and bubbles and churns around. You'll have noticed this on a hot day when you're looking out along a long road. You can see sort of mirages and see the shimmering of the air over the hot road. Well, even in the middle of winter, you still have the same issue. Not nearly as bad. And when it's the object you're looking at is high overhead as opposed to low down, you're looking through less atmosphere high overhead, so it's better then. But you can see right now, even though it is at the moment high overhead and we're in the middle of winter, lost the camera again, sorry, you can still see it is still shimmering. So that means that we're not going to get a very good image if we just take a single frame from that. So astrophotography of a planet and the moon, you take hundreds, if not thousands, of still frames of a video essentially, and each of those frames captures that instant, like a hundredth of a second. Then what you do is you use this fantastic software. There's a couple of different pieces of software. One's called AutoStack and one's called Registax, and they align the planet from all the frames so that it's in the same spot, because you can see it's sort of bouncing around there. Then what it does is it uses computer vision algorithms to go through every single one of your, say, 5,000 frames and pick the best 20%, the ones that have got the least shimmering, because the shimmering comes and goes. You get moments of stability. Then with the 1,000 frames you've got left, it then combines all those frames by examining each part of each frame and picking the best part of those frames and then sticking them together. So it's called lucky imaging. So you take a whole lot of images and then you pick the best parts of the best images and stick those together. And then you come up with the final image and you can process that to make it look sharper and cleaner. So planetary imaging is an entirely different challenge than nebulae and galaxies and what we call deep sky objects. So if you are asking me what telescope should I buy to take photos of planets and nebulas, unfortunately the answer is there's no one telescope that will do both as well as you could. If you want to do great with planets, then it's not going to be as good for nebulae and vice versa. So pick a favorite subject, or unless you've got lots of money and lots of time, you can buy a set of equipment for each. But it's best if you probably stick with one of those. All right, let me just have a quick check back on the questions. So lots of people saying thank you. That's wonderful. I'm very happy to see that you're enjoying yourselves. Claire asks, can I watch a recording of this at a later stage? Yes, I am recording this. I don't know if I'm going to make this available via MBO, because this is very much a test. Lots of things going wrong. But I might be able to edit it down and put it on my own YouTube channel or something, but we'll just see how we go. Oh, we've got a request for Saturn. Yeah, I understand. Saturn is amazing. You want to see the rings. So let's go over there. Lorraine asks, have we ever seen a UFO? And I love answering this question because many people in the public ask this question. And it's easy to answer just by saying no. But the thing is, amateur astronomers, not just astrophotographers, amateur astronomers look at the sky more than just about anyone else. So we spend years and years spending hours and hours looking up at the night sky. And I don't know a single astronomer, amateur or professional, who's ever seen what most people would call a UFO, an alien spacecraft, a flying saucer or something along those lines. I've seen lots of UFOs, things that I don't know what they were and couldn't identify. 99% of them I've later been able to identify. Oh, here we go. Here's Saturn. Saturn is quite a bit further away than Jupiter, a lot fainter, so I need to increase my exposure settings a bit to see it better. So yeah, many people have spent many hours looking at the night sky, and we've never seen anything that we would say was an alien ship or anything that most people would say when you ask them, have you seen a UFO? The sort of things that we consider UFOs are usually end up being things like satellite rocket motors. When satellites change their orbit, they let out a puff of gas or dust, not dust, sorry, a puff of gas, sort of rocket exhaust. And if it's in the right place at the right time, they can get lit up by the sun, and it looks like a strange triangular shape that sort of grows and fades over time. I saw one like that a number of years ago, and it was really quite amazing to see. Totally bamboozled me, but there were other people around who knew what it was, and that was cool. So those are the sorts of things that we see as UFOs. Things that always have a rational explanation even if you don't know what that is yet. As for aliens, no. If they came all the way here, because traveling the distance between stars is huge, it's really difficult, they wouldn't just be floating around in the night sky waiting for people to take blurry photos of them. All right, so let's just do a quick discussion about Saturn here. You can obviously see the rings, which is fantastic. You can see the disk of the planet. One feature that you might not notice, but this is very cool, is see this little notch here between the planet and the ring? That is the shadow of the planet on the ring. Okay, so we're seeing that little dark part there. That's the part of the rings that can't see the sun right now because the Saturn body is blocking it. You might also see, and this is a bit harder, just on the left here, the rings sort of have a little bump. That's the bottom edge of the disk of Saturn just poking out. So you can see the rings are sort of tilted relative to our viewpoint. As Saturn goes around the sun, the rings sort of stay in a sort of a fixed angle. They don't wobble backwards and forwards, but as it goes around, you can imagine that it gets to a point where when you're looking at it from different angles, it seems to be more open or more closed. And there's a point in time where the rings are edge on to us and you can't see them at all. And that only happens for a couple of weeks or so. But they are very, very thin line and then disappear. And then a week or so later, it's a very, very thin line again as we pass through that plane. And ironically, when Galileo first turned his telescope to the stars, the planets obviously were things he wanted to look at because they were so bright. He looked at Jupiter first and he saw the moons, which was amazing. That was the first evidence that not everything in the solar system rotated around the Earth. But when he looked at Saturn, he thought it had ears. His telescope wasn't anywhere as good as mine, even though mine's not ideal for planetary work. He thought it had ears. Then he went back and looked at it a few months later, and the ears had gone, which totally confused him. Just turns out that the time that Galileo went back to look at Saturn again was when the inclination of the rings was matched to the Earth's position, and so they effectively disappeared. And yeah, when he looked back a few months later, they came back and he was completely flummoxed. He had no idea what it was. It wasn't until I believe Christian Huygens looked at it again that he correctly discerned that they were rings rather than other bodies orbiting Saturn or ears as Galileo described them. He didn't think they were really ears, of course. All right, let's go back to our previous settings. And since we now have Saturn centered, actually it's not quite centered, so let's just put that in the middle. I'll turn on some guides to help me. I just realized I've been spending a lot of time talking and not nearly as much time imaging as I was planning to. I hope you don't mind, folks. I consider this a bit of outreach and education as well, but this is just a bit of fun, sort of hanging out and chatting and looking at the stars. So now that we've got Saturn centered, we can update the pointing model. You can see it was very close. So we can sync that. All right, now let's go back and try M8 again. So hopefully it will be a lot closer this time. All right, while it's panning, let's have a look. My 10-year-old asks, why is Saturn always looking sideways? Not entirely sure what you mean by that, but if you mean that we see Saturn from its side rather than from the top or the bottom, that's because the Earth and Saturn both orbit the Sun in the same plane. So if this is the Sun, the Earth goes around like this, and Saturn goes around like this. It doesn't go around like that. Okay? So if it was going around at a different angle, or if we were at a very significant different orbital plane from Saturn, we might see it from above or below, from different broader angles, but we don't see it from, we'll only ever see it from its side, just about 30 degrees above and 30 degrees below the rings. All right, let's see if we've got the Lagoon Nebula now. And there we go. It was worth the wait, I promise you. So this here is called the Lagoon Nebula, also known as M8, or as I call it, MATE. The name Lagoon comes from this dark area in here. You can see that sort of patch there. That is sort of called the lagoon in the land of the nebula. And this is, aside from the fact that you can see colour in this is kind of what it would look like through a telescope, a decent telescope with an eyepiece. So the lagoon there is sort of quite dark, but everything is fairly faint. But we have a camera attached, And cameras can do a lot better than that. So let's go from our finding target preset to our imaging preset. And we should see a single 30-second exposure shortly, but let's go straight into our live stack. So as I said before, and for those who joined recently, stacking is a technique to take many photos of a faint object, then blend them together. Because the noise is random and varies between each frame, but the stars and the nebulae are static, they stay constant between each frame. When you stack them together, the noise averages out and the stars and the nebulosity adds together. So over time and more frames in your stack, you get to see much clearer and more detail in that image. And you can already see here from a single 30-second exposure, this nebula is beautiful. It really shows a lot. So let's move that out of the way a bit. And we'll zoom in on that to 100%. And just as a reminder, I'm binning here at 3x3. That means it's grouping every 3x3 pixels into 1 pixel. So we're getting 1/9 of the resolution that this camera is capable of, but it means it's going to get the same, collect the same brightness faster. So if you see here, you've got noise in the background there. Let me zoom into 200%. So you can see here, we've got quite a bit of grain, okay? It may not come across clearly on the Facebook stream because of compression, but believe me, it's there. The more stacks, the more frames that I stack, the smoother that noise becomes, and the more that I can push the processing. So you can see here, there's sort of some faint nebulosity there, some faint pink stuff. That I could make brighter, but if I did it now, then it would make the noise brighter as well. And I don't want to have the noise being as big a part of the image as the nebulosity. So taking more photos, averaging out the noise, that lets me brighten up those areas without the noise becoming as big of an issue. So I can make very faint objects become much brighter. Now we've got 3 frames, that means a total of 90 seconds, so a minute and a half. I'm going to zoom back out. And I'm going to play with a histogram down the bottom here. So just a quick explanation. A histogram is a graph which shows the distribution of pixels and their brightness. So on the left here is dark pixels. On the right here is bright pixels. And the vertical axis is how many there are. And you can see there's quite a few here that are just sort of blobs of black. But then it jumps up here in the greys and then fades off into the whites. So this area here is the nebulosity. And these areas here are sort of the stars, and this stuff here is the background. Now, I have dragged this slider here up, so it cuts off all that stuff in the background. That is just grey, we don't need that. We're going to bring it up until we get to the bottom of this peak, which is where the nebulosity starts. So the sky will go blacker. The whites, we always leave it white, because if we drag it down, that just overexposes the bright bits and blows out the stars. We don't want that. If you want to make the picture brighter, we drag the mid-level. So that will allow us to come up to here. So I reckon I can even drop that black point, or bring that black point up further. Yeah, that's looking good. Okay, so these peaks here are obviously the background sky, not the nebulosity. So by increasing that, I've got a bit of contrast back, so let's bring the mid-level down a bit to brighten it up. And yeah, look at that. Now that's something you can't do with short exposures and not a lot of noise. I like the white balance there, but I'm going to make it a little bit more saturated. That's just making it brighter, not more saturated, isn't it? All right, let's just try resetting that and going with that default or the auto. It's a bit too red, a bit too blue. Yeah, that looks about right. All right, so while it's continuing its stack, let's zoom back in again and see if that noise has improved much. So zooming into 200%. And okay, there is still noise there, but look at that pink nebulosity. Remember the last time I zoomed in here, it was barely visible against the background? Well, because I've played with the histogram, that means I've brightened that up. And even though it was full of noise, it's still got noise, but nowhere near as much as it would have if I had brightened it before I did the stacking. We've only got 8 frames stacked so far. If I was to continue to 30 or 40 frames, then the noise that's visible in that would fade away and eventually you'd go to nothing. But that would take many hours of exposure time to do that. At the moment, we're just doing a quick tour of the night sky. So I'm not going to be doing that long. That's what I would normally do though. But it's great that the gear that I've got lets me get these fantastic preview images even with only, 10 frames of 30 seconds. So 5 minutes? Let me just have a quick check of the chat. Let's see. People are enjoying it still. That's great. Can I see comets and meteors with the scope? Meteors, no. Although once I did. Meteors go by so fast that it's just pure luck if you happen to see one through a telescope. You'd be looking at something else and you'll see a flash streak through. That happened to me once. Very rare because it's very hard to, or it's very unlikely that the small field of view you're looking at will have a meteor go through it at that instant. But I did once, very lucky. Comets, yes. Comets are fairly faint and diffuse. These nebulae, they're also faint and diffuse, but they're brighter further out. Whereas comets, they have a bright nucleus that sort of is fuzzy, and then outside that is a much bigger coma that you probably can't see through a telescope. It comes up well in photographs. There hasn't been a good comet that I've been able to photograph for a number of years, so I'm hanging out for another one to come back. I've never really got a photo of a comet that I'm happy with because there weren't any good ones around after I'd learned what I was doing, and when I didn't know what I was doing was when there was a good one. So hopefully we'll see you again soon. Okay. Roya says, this is so educational and you have a wonderfully engaging style. Thank you very much. I really appreciate that. You love the mini doco on videos on Jupiter on the night too. So awesome. Andrew did a wonderful job with his tour of Jupiter. Andrew was very, very popular. People really enjoyed his presentation. So Clive asks, are these nebulae H1 regions, ionized hydrogen? Yes. So let me zoom back out. Oh, wrong button. We'll go to auto. So we'll see here, this is a very sort of reddish pink nebula. In the middle, it's a little bit more orangey. That red that you see there is ionized hydrogen gas. So a quick explanation, quantum physics 101. An atom has electrons orbiting around it. When energy is hits an atom, the energy is absorbed by the electron, and it's orbiting at one level, but the energy causes it to jump up to the next level. It holds onto that energy for a little while, but it doesn't stay stable. It has to get rid of that energy. So when it drops down a very specific amount. That is from one orbit to another. And that specific amount of energy, when released, happens to be a photon that has the energy equivalent or the same energy as a wavelength of light of this pink color. So this happens with hydrogen. So all the high energy UV radiation, mostly from the nearby stars, that are absorbed by the atoms, the hydrogen atoms, they get spat back out in this specific pink color. Hydrogen also has a second level. So if you go up 2 jumps, I think it is, and it jumps down 2, then it spits out in a different wavelength of light, which is sort of a teal color. That's called hydrogen beta. That is nowhere near as strong as the hydrogen alpha, so the pink of the hydrogen alpha usually overwhelms it. There are 3 emission wavelengths that astrophotographers usually focus on, called hydrogen alpha, sulfur 2, and oxygen 3. So doubly ionized sulfur and triply ionized oxygen. Doubly ionized sulfur is very red. It's almost the same color as the hydrogen, and triply ionized oxygen is sort of a greeny blue, almost a similar color to the hydrogen beta. And we can use narrowband filters to block out all light but those, and that gives you higher contrast images, but you can't get a natural color image because you need red, green and blue, not red, red and teal. So if you ever see a narrowband image like most of Hubble's photos, then they're false color because they assign red, green and blue to those channels. Okay, let's go to another object. Because many of you folks, I would imagine, weren't here right from the start. Quantum Physics 101, haha. Thanks, Lisa. I'm glad you like that. That was very, very basic. But let's go off to a nearby object that we looked at the start that has an example of different colors. So we've only seen sort of the red so far. We'll go to M20, also known as the Trifid Nebula. It's right next door. That's the object we were just looking at. It's just out of the frame. So let's slew to that. And we'll take the, stop the live capture. In fact, I'm going to save that and post it to the MBO site afterwards, so you guys can have a recollection of what we did. But we're going to clear and stop and go over to our finding target preset. And you can see the star trails there, which was the last image taken while it was panning. So here you could just see very faintly, there's sort of a reddish colour with sort of a Y shape going through it. That's the Trifid Nebula. And this is kind of what it looks like through a telescope. Again, you don't see the colour because the eyes aren't sensitive to colour in low light. You might be able to see a sort of a faintish bluish colour over here. So that's giving us a hint at what we're about to see. But this is kind of what it looks like through a telescope, but in black and white. But with cameras, again, we can do much better than that. So we'll go to imaging and live stacking. So in a few seconds, we will see a preview of that. Simone, you've been here from the start. Thank you very much for hanging around. You're about to drop off, but you want to see the Trifid Nebula? I don't blame you. It's a beauty, that's for sure. Neil, this is just about the highlight of this lockdown. Thank you so much. You're welcome, Joanna. I'm glad you're enjoying it. We had a few teething troubles at the start, but we seem to have got that worked out now and things are working better. So I'm glad you're enjoying it. Okay, it's not working out again. So what have I done wrong this time? Let me just check my settings. So we've got 30 seconds. I've got low gain, that's fine. What about, no. All right, it's possible that it has set below the local horizon. So we might have missed our chance for the Trifid tonight, unfortunately. Of course, it also might be something wrong with my gear. So to make sure that it's not, I'm gonna clear that, close it, go back to our finding target, load that, and let's just see if it's still there. It is still there, okay. All right, let's not do a stack. Let's just do a image, single image, and see what it comes up with. All right, so we're doing a 30-second exposure now. Heidi asks, would love to see Andromeda. So would I. Unfortunately, Andromeda is very far to the north, so we only get to see it maybe 2 months of the year, and that's in summer. And even when we do, because it's so far north, it doesn't get very high in our sky. It only gets around about 20 degrees above the ground. I'll explain how to find out what that is in a second. But that means that because my location here, I don't have access to a north sky because the telescope is on the southern side of the house. So I can't see to the north. So I'm afraid I can't show you Andromeda. We just got a preview of the Trifid there, which I'll get to in a second. So degrees, easy way to find you around a way around the sky. You need to sort of know how to say how far things are. You can say that this star is just to the right of that, or halfway down from the other one, but it's easier to actually talk in degrees. So if you put your arm out at arm's length, let me see if you can see on the camera where I'm pointing, your thumb covers about 1 to 2 degrees wide. Your fist covers about 10 degrees wide, and your spread fingers covers about 20 degrees. So if I said that Andromeda gets about 20 degrees above the horizon, put your arm out, spread your hand, and put your pinky on the horizon, and that means that Andromeda would be about above your thumb. Okay? Now, you might say, my hand is smaller than my friends, so how is it always the same? Well, people with smaller hands have shorter arms, so they're closer, and it's about the same. It works out pretty well. One of those unusual and awesome coincidences. All right, well, since this works, let's try the live stack again. So we'll start off, hopefully this frame will go into it now. Okay, let's have a look at some questions. Please keep your online reach going in the future, as not everyone will be able to visit in person. Absolutely, yeah, we've been so thrilled with the response that we've had to our online outreach that we would like to continue doing stuff like this past the lockdown. There we go, it's working now. So we have only just started doing this now, so we obviously have a lot to learn, and there's a lot of time to do that yet before we get back out of lockdown. I don't think we'll be going up to the observatory for probably several months more. So that'll give us time to get a much better handle on what we're good at and what people like and don't like. And that will mean then that in the future we'll have better content for people. We'll be able to use that as part of our outreach. So let's play with the sliders here. So that's already looking quite nice, isn't it? Now the Trifid Nebula is quite a lot smaller than the Lagoon Nebula, as you can see. Before, the Lagoon was taking up the full vertical size of the frame. So let's zoom in on that. We'll go to 100%. How nice is that? Let's go to 200 and you can see the noise. So see this grain in here? That's already after 3 stacked frames. So if we give it another 5 minutes, you'll see this grain, this noise, slowly sort of smoothen out and become less obvious. That'll then mean that I can do a bit more contrast and I can make things look a little bit more punchy. That will bring some of the noise back, of course, but it will still look nicer. So while this is getting some more subs, I'm going to have a look at the questions again. Marie Gilbert asks, Neil, this is a bit off topic, but do you know about the phosphine discovery on Venus? No, I don't. Thank you for making me aware of that. I'm going to search for that phrase and come back to it after the live stream. I don't really have the opportunity to do that right now, to look at it right now, but it sounds interesting, so I'd like to look into it. Is Mount Bennett Observatory wheelchair friendly? Unfortunately not. The observatory and the log cabin were built in the 70s for the students at Monash University. So back then there wasn't as much consideration given to accessibility standards, and I don't know if any of the students had accessibility issues, but it wasn't a consideration when they designed it. Now since then, since we've taken things over, we've done whatever we can to try and make any additions or alterations we've done make accessibility better. But unfortunately, we're very limited to what we can do, partly because it's a historic building, so we can't really take out the stairs and put in a ramp or broaden the door and stuff like that. But also because we don't have a budget to do that sort of stuff. We sort of run on memberships and occasional grants. And that's enough to keep us going and do some of these cool things like outreach and buy equipment for the members. But to do some of the things we'd love to do, say for example, we want to make the log cabin, which is where we have our meetings. We want to broaden the door. We want to put a shallower ramp into the door. We'd like to have disabled access toilets, that sort of stuff. That would cost tens of thousands of dollars, and that's sort of beyond our budget at the moment. But it is a high priority for us. We do want to improve the accessibility there. If we are able to get lots more interest and lots more members signing up through our outreach, which has become quite successful online, then hopefully that will provide us with more funding and give us the opportunity to do that. It also means that with more people coming up, we can go to the council or to various politicians and say, look, we've got this fantastic resource and yet we're not accessible, or at least not as accessible as we'd like to be. Give us money. And hopefully they'll be able to assist us with grants and make that happen. So it is really important to us. We really want to do it. We have a diversity officer, and accessibility is part of the diversity portfolio. So it is on our minds. But right now I'm afraid that people in wheelchairs wouldn't be able to go up to the main dome, and it might be a challenge getting into, if the wheelchair's especially wide, getting into the log cabin or using our toilet facilities. However, there are a number of telescopes that are very portable that we use. They're called Dobsonian telescopes. They just sort of have a simple up, down, left, right function. Very easy to move and point, and they can absolutely be used by people in wheelchairs. Other people with accessibility issues as well. So if you want to come up to MBO and you have accessibility issues, it might be worth giving us a call ahead or sending us an email at info@mbo.org.au, to let us know what needs you have and help us better accommodate you. But we will absolutely make sure that there is something that you can see and do. We don't want people to go home without enjoying themselves, even if it's a cloudy night. We'll do something to make things interesting. So yes, the answer to that, or very long answer to that question is no, but yes. So we're working on it. And now we've been doing this for a while, you can really see that grain has smoothed, that noise has smoothed right out. So I'm going to play a little bit with the histogram and see if we can make that better. I lost my camera again. I think it automatically shuts off every half hour, so I need to find the settings to change that. I'm using a digital SLR hooked up to my computer. So let's up the contrast a little bit by darkening the blacks. Oh, that looks good, doesn't it? Maybe a bit too much there. And then brighten up the mids. Oh, look at all that faint nebulosity there coming into the shot. You can see there's a lot of faint blue stuff in the background there. That wasn't visible at all against the noise before, and we've only been shooting for 6 minutes. So yeah, that's pretty good. All right, I'm going to save that, and let's go to something else. So we had a request earlier for Mars. Let me see if Mars is up. Okay. What time is it? It's 9:30, so I'm going to advance my planetarium software, which I don't think you can see here, to 9:30. Actually, I can use the planetarium software on the screen that I'm sharing. Okay, so we'll zoom out. And let's see, we'll do a search for Mars. No, it's way down the horizon right now. Won't be able to see that from where I am, and even if I could, it will not be a good view because it's through so much atmosphere. Oh, Heike, I know you're trying to send through some of the questions, but your typing has degraded as you've had more wines. I'm sorry. What ionizes the nebula has? I'm sorry, I don't know what you mean. Okay, let's find another object. Let's see. Courtney says, love how excited you get with these amazing pictures. I really do. I love photographing the night sky. I love seeing these awesome objects. There's just so much cool stuff up in the night sky, and it's so easily accessible to the amateur with a relatively small budget. People always ask, how much did all my equipment cost? I got started. I've got more sophisticated equipment now, but I was still taking amazing photos, if I say so myself, with gear that I bought secondhand, so a telescope, mounts, guide scope, a few other accessories for $1,800 secondhand. So you don't have to break the bank to get into this. And even then, you can just start with the digital SLR that you have and a tripod, and if that's what you've got, if the digital SLR is newer than 5 years or so, that's ample. You can take amazing night sky photos, maybe not of specific objects like nebula, but of night landscapes with just that, an SLR and tripod. Again, search for my name, Neil Creek, and the word astrophotography on YouTube, and you'll see my lecture to MBO on getting started in astrophotography, and that talks about using a digital SLR. Let's try a different object this time. It's a globular cluster. And I'll explain what that is when we get there, but it'll be pretty self-evident when you see it. So I'm hoping it's above my horizon. It should be. Okay, Tanya Moore says, talk about gear for about $500. Okay, so assuming that you have an SLR and a tripod, then for $500, I would be recommending you purchase a tracking platform. So that's like a mini telescope mount. It goes between the tripod and the camera. And when you align it so it's perfectly south and it has the correct elevation, then you can use longer focal length lenses with longer exposure times because it follows the stars. So if you use, say, a 135mm lens, which is a nice good zoom, pardon me, the tea's coming back on me, and you use, say, a 2-minute exposure with a good polar alignment on a $500 tracking mount, you can get amazing photos, and you can take a whole bunch of them and then stack them. So you can get nebula photos with just an SLR tripod and a $500 tracking mount. The one I recommend is called the Skywatcher Star Adventurer. Okay, it's a bit of a mouthful. Skywatcher's the brand, and Star Adventurer is the mount, or the tracking mount. So do a search for that on Google, and you can get them for about $500. And it's a challenge to learn how to polar align it. But once you figure that out, then that skill will translate over into every other polar aligned telescope you use in the future, and you can get amazing results with that. So that's where I would start for that budget. All right, so what have we got here? We'll go away from our imaging and into our finding presets. We will zoom back out to fit, and it looks like we're going to have to do a little bit of a spiral search for this one, but it shouldn't be too far because we've been updating our pointing model every time we visit a new object. Okay. Again, while I'm doing this, I want to be able to answer questions, but I can't scroll because I need to hold my mouse on the button to do this. I also just want to say thank you very much to Heike. She has been the voice of MBO in the comments that you've been seeing tonight. She has been very helpful, and it was done on very short notice. An hour before I went live, I said to Heike, "Hey, I want to do this. Can you help?" So she very graciously set herself up with her laptop and a glass of wine, and has been enjoying keeping you company and answering your questions while I've been busy with the telescope. So thank you very much, Heike. You've been wonderful. Okay, looks like it's struggling a little bit with this one. So maybe I've come too far across the sky for it. The further you go from where you last did the position model update, the less accurate it is. So I might go to a different object that's a bit closer to the others, find that, center it, and then update the model and try this one again. The night sky is a big place, and the telescope has a small field of view, so sometimes it can be a bit tricky to find things. All right, I'll give up on that for now. I'll come back to it. All right, so let's see what else have we got we can try. That's a bit closer to where we were. So we were over here. So it really is on the opposite side of the sky. My cat just walked through and bumped my microphone. Sorry about that. So, all right, what about, let's see. I hate controlling this Planisphere software. It's not very intuitive. Okay, so what's over here? That might be too far. Yeah, that's too far north. All right, we'll go back to the west. Heike asks, am I finishing? Not yet. I'd like to keep going if people are still interested in watching, and we've still got 268 people here. Heike, have you needed to block any spammers or get rid of any people causing trouble? Because if so, then if you want to go, then I'll finish. But otherwise, we could just keep going without you. I mean, you've been wonderful, but I don't want to keep you up all night. Let's see, what have we got here? Okay, this is looking a little blurry on my screen because this is coming over a network connection, so it compresses things and makes them a bit blurry. It's a bit hard to see. Let's try M7. That's in the same area. Actually, I'll find it this way. M7's a nice open cluster in the middle of the galaxy, and it's got an amazing backdrop of stars. So we'll try that. While we're panning, let's see questions. Amy says, I'm an hour behind putting the kids to bed. Sorry. I hope you've enjoyed it. I hope it's worthwhile, and I hope the kids aren't too much of a terror tomorrow, but I'm glad you thought it was worth it. Mars will be clear being closer. Unfortunately, it's still too far down the horizon. This is so good, I switched off the TV. Nice to forget about COVID for a while. Thank you, Ian. I really appreciate that. And yeah, it is good to forget about it for a while. Okay, here we go. So it's pulling in the right spot. So let me just update the model before I forget. So telescope, sync M7, and yes, it is pointing there. We'll just do a very quick stack on this one because it's a cluster, and clusters don't really need a long stack because they're stars, and stars they come through in exposures pretty quickly as opposed to faint nebulosity, which takes a lot longer. So we'll do a couple of minutes on this, and hopefully we'll be able to go to the 47 Tucana globular cluster after this, after we having fine-tuned our model a bit more. Let's scroll back a bit further, see what else we got. Jim says, my 10-year-old asks whether you can see the International Space Station. Yes, you absolutely can. We had a post on our website on the Facebook page maybe a week ago now, just after the last stream, and it was alerting members of the page that the ISS was going to be passing overhead that night. We had quite a few people able to see it. So it's quite bright. It moves moderately fast, so faster than an aeroplane appears to move, slower than a meteor, and it just looks like a sort of a bright star or even like a planet that just sort of slowly passes across the sky. It takes about 2 or 3 minutes to pass across the whole sky. It doesn't always appear here because its orbit takes us over us at different points. It can also be, you know, towards either horizon or overhead, just depends on what its orbit does. It also depends on the time of day. The earlier in the evening, the brighter and the longer it will appear because it's more illuminated by the sun, but of course the brighter the background sky is, so it's harder to see against that. The later in the evening you go, it's a bit fainter, the sky is darker. It also will be more likely to pass into the Earth's shadow while you're watching it. So you will see it be bright, 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 and then over about 5 seconds it'll fade out into nothing, and that's when it is experiencing its sunset. So the sun is on it until it passes into the Earth's shadow and then you can't see it anymore. There is a few apps online that you can download for your phone that will send you alerts to say when there's an ISS pass happening. So try going to your app store and doing a search for ISS or satellites. That will hopefully find something that will help you. So we're currently using the same stretching settings that we were on the previous one, so it's not looking right. So let me tweak that a bit and see if we can find the object. Okay, it's not liking it again. So it keeps doing this and I'm not sure why. Ow. My cat's making biscuits on my arm. Ow. Sorry, mate, you can't do that. All right. All right, let's stop this then. We'll clear it. Clear. Actually, I did notice that frames ignored was 5 before, so let's just see what's going on here. Noticing people are helping out answering questions in the chat. Zafar, thank you for suggesting the app. It's also great if anyone else wants to answer questions and they have knowledge that can help other people here. Thank you very much for doing that. Oh wow, the auto stretch really isn't good. All right, we'll reset that and I'll do it manually. Okay, it's a little bit dark still. That color balance is a bit better. Okay, now we've got a better histogram. I can see what I'm doing better. Okay, that's starting to look good. Let's zoom in on that. Yeah, that's nice. So if we go back out again, sorry, just quickly, you can see these brighter stars here in the foreground. Most of those are part of this cluster. So this is called the Ptolemy cluster, or a Messier 7. And it's a cluster of sort of hot young stars that formed near each other, formed together and are slowly drifting apart. There are a couple of yellow stars here you can see. They're foreground stars, stars that are in between us and the cluster in the background. Heike's just telling me that her laptop battery is running out, so we may not have a moderator for much longer, but I haven't seen any trouble in the chat, so I don't think there's really anything going on that we need to worry about. So Heike, if you need to go, feel free, and thank you very much. Everyone, please send Heike a thanks. Yeah, I think I'll keep going for a while longer because I'm having fun and you all seem to be having fun. So yeah, this is a beautiful cluster. And so, as I said, you've got the foreground stars here, the yellow ones. You've got these stars, the blue ones in the cluster, but behind it, you've got this curtain of stars, which are part of the Milky Way galaxy. So we're looking towards the center of the Milky Way here. So there's a backdrop of thousands and thousands of stars, which even more show up with longer exposures. If I zoom in even further, you can see that those dots, we've got enough photos now where there's not much noise left. Those dots are all stars. And that's a tiny section of this image. If I zoom back out again, you'll be able to see all of that is stars. So it's really quite amazing here. All right, let's try 47 Tucanae again. In fact, I'll save that one as well. I keep forgetting to save them. I think I've got 3 now, so we can share that later. Misspelled. All right, let's slew to that, and hopefully it's a bit more accurate this time. Okay, I keep seeing people asking for Mars. I'd love to, but at this time of year, Mars is only just above the horizon for me at the moment, so unfortunately, it's not visible to me. I'd have to be waiting until 3 or 4 a.m. To get Mars on screen. So I'm afraid not tonight, but it may be possible in a few months. Or however, there may be other members who have the ability to stream their telescope who have a good eastern horizon where Mars rises. So they might be able to share it for us, for MBO in the near future. So let's see if we've got it this time. Go back to our finding. Okay, still not centered, but we might be a bit closer. So let's just do a quick spiral search. And if that doesn't find it, we'll give up on that one. Mel asks, what software do you use for all of this? Combination. The software I'm using to control the camera is called SharpCap. One word, SHARPCAP. This is what I do for live imaging or for planetary imaging. I use another tool called Sequence Generator Pro for my long sequences of images, which I use when I'm doing, say, multiple hour exposures of nebulae that run all night. The control software for the telescope is called EQMod. That's a free utility. It doesn't do much, but it lets every other piece of software on your computer talk to the telescope. So it's a two-way communication between the telescope mount and the software. So that's an essential piece of software if you're using a kind of mount that EQMod is compatible with. So there's lots of different manufacturers, lots of different mounts that are slightly different from each other, and sometimes you need different software to control it. So there's no real overarching user interface or standards that apply to everything. So it's a bit of a wild west in astrophotography. So you need to learn a lot and wrangle with lots of different pieces of software to get things working just how you want them. We had a question earlier asking about images of the moon. Unfortunately, or fortunately, depending on your point of view, the moon's not up tonight. The moon is great to look at when it is up, but when it's up, it's usually so bright it drowns out everything else. So I can't show you the moon tonight because it's not up, but maybe on a future stream, we might be lucky and have the moon up and clear skies at the same time, and I can show you then. All right, no luck finding 47 Tucanae, so I'm afraid we'll have to skip that one tonight. I am just going to look at my planisphere on my computer, which tells me a bit better what is visible in my sky at the moment because it's got an artificial horizon on it. So, when I say artificial horizon, it simulates what I can see from my location. So I've got a line going around the planisphere view that goes where the trees are, where the buildings are, so it'll tell me if I'm going to be blocked by looking at something. Did you hear my cat then? Let's see. You probably heard that, didn't you? Okay. Okay, I saw a hiker ask earlier, is there a cat nebula? No, but there's a cat's paw nebula, and I think that's up at the moment. So let's see if we can get to that. So that's NGC 6334. NGC 6334. Okay, let's center on that. It might be getting a bit low to my horizon. Wrong button. But we'll give it a go anyway. Someone asked my cat's name. His name is Aki. It's Japanese and it means autumn, which is when I got him. I guess you can see him walking back and forwards in front of me, or at least his tail. Hang on, while it's panning, I'll give him a hug and bring him over. There he is. He doesn't like being picked up, especially when he's hungry. He's always hungry, which is why he's here annoying me, because he wants his supper. He wants his evening snack. But he's a good boy. He's very fluffy and cute. Alright, so let's see how close we are to the cat's paw. Now this is going to be a little bit harder to find because it is a faint object. So it may not appear in the preview, but I think I can just see something here and something here maybe. So rather than going to my straight onto the stacking, I'm going to do 5-second preview frames, and that might be enough to bring it up. Okay, so that's obviously overexposed with those settings, so I'll drag down the gain and see if it pops up there. Cute ginger ninja, he certainly is. Although he's not always a ninja in the middle of the night. He likes to tear around the house, thumpity 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 thump. I think everyone's cat does that at some point. Yes, it is there. Very faint, but it's worth it, trust me. So we will go over to the imaging preset, load that, and go to a live stack. All right, so while that is stacking, let's have a look at questions. Cameron asks, what is in the upper top right? I'm not sure what you're referring to. Is it in the image or is it in my controls? So if it's in the image, you will see it shortly when it's part of the stack. But if it's my controls, this is just the control panel for the camera. There we go. Okay, it's faint, but you can see it coming in here. We'll give it a few more subs, then I'll play with the histogram, and that will hopefully make it a little bit more obvious. You can see the cat's tail nebula. That's a great name for a nebula. They should name it that. Or should name something that. There's an elephant's trunk nebula, which looks just as much like a cat's tail as an elephant's trunk, I reckon. Wendy asks, how do you remember all the names and numbers of the nebulae? The names you get to know, especially because there are maybe 50 really great objects in the sky or so. You learn them pretty quickly. The numbers are a lot harder. If you say spend a week imaging an object or looking at an object, then you'll remember its number, but 6 months later, you'll go, oh, what was that one called again? Fortunately, we've got lots of catalogs and other references that we can reference. Heike just told me that we're getting a few new members, which is wonderful. I'm so happy to hear that. That's terrific, folks. We're a happy, friendly bunch here at MBO. We love doing outreach and bringing the wonders of space to people. And she also told me that my cat is a star. She's not telling me anything I didn't know already. But I'm glad you all like him. All right, we've got 4 subs now. So let's try playing with the histogram a little bit. So this is a relatively faint one, but I'm starting to bring a bit out there. Yeah, there we go. That's starting to come through. Let's try tweaking the color balance. No, that didn't work. Oh, that's better. All right, let's zoom in on this one. We'll go to 100%. So yeah, because this is faint, I've had to brighten things up quite a bit. And even after 5 sub exposures stacked together, you can see there's still a fair bit of noise here, a bit of grain in the photo. So with fainter objects like this, you need to spend a lot more time on it. So we've got only 3 minutes here so far. If I was to sit on this one for an hour, then the noise would be smoothed out a lot more, which would mean that I can push the histogram further without the noise becoming too obvious. And that would mean that the nebula can be brighter relative to the background. And so that's why we need to do long exposures to get these faint objects. We'll go to 50%. So it's starting to come through here, and it's not quite centered. So that's not helping me either. But you can see here, we've got 1, 2, 3 toe beans, and this here is the pad of the paw. So, you know, cats have the sort of the pad and then their toes, toe beans affectionately. This is what the nebula is sort of, it reminded the people who named it, what it reminded them of. And I agree. I think this is one of the few nebulae that actually look like what their name is describing. But I actually have an image of this that I've taken before. Now, I'm sharing the laptop screen, which is what's controlling the telescope through the network. I'm sharing that on the Facebook stream, but I'm not sharing my own desktop. So I'm going to have to load that on the laptop. So I'll bring up the image to show you, but it might take a few seconds to load because, as I said, it's a very old, slow laptop. And I don't really, there we go. We've already got it open here. So this is my astrophotography portfolio. I don't know if you can see the address there. If you want to go and check it out, you can go to that address. It's neilcreek.smugmug.com/folio/astrophotography. I'm not entirely sure if the capitalization is essential, but give it a go. Also, sorry if I'm offending anyone, there's a couple of art nude photos amongst those. So if that is something that concerns you, please be aware. But where did I put my cat's paw? Oh, maybe I didn't upload it to the folio yet. I took it a while ago, but okay, I must have neglected to. All right, I will, what will I do? I'll upload it to that from my computer on my desktop. So I can do that in the background here. Actually, no, that'll take too long. I don't want to interrupt things. I'll post that to the Facebook group later, so you can see that separately. Okay, so, all right, we've got a little bit more data now. We've got 5 minutes, 30 seconds. Let's see if we can do anything else with this. Yeah, we've got a bit of a problem with vignetting here. So the edge of the frame is too dark, and the middle is sort of a bit paler. So if I increase the contrast, it just makes that difference greater, and it doesn't bring out as much of this. So I might drop that back to make everything a bit lower contrast, but brighten this up. Yeah, okay. So this is an object that needs a bit more time and a bit more processing. Also, it'd be better if it was centered. Because it was so faint, I couldn't see immediately when I started the sequence that it wasn't centered. That would mean that the interesting stuff here wouldn't be too close to the edge and part of that vignette. Also, the vignette is a natural artifact of the way the optics of the telescope works. There is something you can do about that. You can take what is called a calibration frame, where you take photos of an evenly lit surface. So the only detail, I've lost my camera again, got to sort that out. The only detail that the calibration frame captures is the vignette, and that's called a flat file, because what you're trying to do is make the background flat instead of have a variation in brightness. So when you have that flat frame captured, which shows the vignette and nothing else, you can take that and put it with the processing software and say to the processing software, from this image, which is the nebula, take away everything that is the same as the calibration frame. So it brightens up the corners. That gives you a flat exposure for the background rather than having the vignette. It does mean that the corners are going to be a little bit more noisy because you're increasing that exposure. But if you get enough sub-exposures, then your processing should be able to tolerate that. So again, as I said, this is a dim image. It needs a bit more time and effort to process, but the results are worth it. Okay, so I seem to have lost, okay, there's the window. Let me just refresh it to make sure I'm seeing the most recent comments. How are you all going, folks? We've been going for an hour and 47 so far. Are you getting bored yet? Where's the video? I'm just loading the stream so I can see to make sure I'm seeing what you're seeing. Okay, so I'll let that go in the background for a second while I look at the text and answer questions. Summer asks, what does the money from MBO membership go towards? A number of things. Most importantly, the land that MBO was built on was, when it was originally constructed by Monash University, they didn't purchase the land, they leased it from a farmer. The farmer allowed Monash to build the telescope there. That arrangement is still in place. So we are paying rental on the land that we are on, so that is one of our biggest expenses. We also have a lot of other expenses like insurance and any legal fees that we have to pay, electricity, internet, all the usual stuff. And that's where most of the income from memberships goes. Any extra though, we use for special projects. So things like purchasing the license for Zoom so that we can do our live stream, purchasing equipment such as telescopes for members to use. And sometimes we have big projects like we installed a second observatory dome up at the observatory location, which now has a robotic telescope, which is specifically designed for astrophotography and hopefully research soon. That was partly funded by memberships, partly by grants, partly by donations. But all of the money that comes into us, it goes back into the observatory and for facilities and stuff for members. Nobody takes a wage. One day we'd like to be able to be successful enough that we can have the observatory open semi-permanently so that it can be a tourist attraction that tourists can come up and visit day and night. When that happens, if that happens, we would definitely need to have some permanent staff. But for the time being, we're sort of self-funded, and all the maintenance, operation, upgrades and stuff that we do, that's where the funding that we get from our memberships goes. How much longer I'm losing? Heike, you can go. You don't have to stay. Heike also tells me that you are posting links and everything for us to help out. Thank you so much. It's this sort of sense of community that MBO was built around. So for those of you that are helping others by answering questions and sharing links, we want you. You're the kind of people we love to have in our membership. We all like to encourage that. All right, what else have we got? What about a galaxy? What galaxies are up at the moment? Let's see. Have I got anything in my observing list? Oh, what's this one? Okay, I'm going to just go to some objects that I've put in my want to image list and may never have actually been to before, and see what they look like. Oh, actually, this one might work. This is a good one that I have imaged before. If it's up, it might be good. So NGC 300, and I believe this is the Silver Coin Galaxy in Sculptor. So we'll slew over there and see if it gets on target, because it might be hard to see this one because galaxies are all faint. Rosalind says, your multitasking has been amazing in your imaging session. Thank you very much. It is a challenge. It's something that you get better with practice. I also have ADHD, and that might help. I can't keep my attention on any one thing for too long, it seems. All right, let's go back to our... I don't think I'll save that one. And not really... It's not the best image. I'll share the one that I took previously. So I'll clear that, close that, and go off to our finding preset. And let's see. All right, so do I see anything in there? Hello again. I might have to go up to a 5 seconds for this one. You know, I've been telling everyone that you should all become members, but I haven't been telling you how. So go to our website, mbo.org.au, and you'll see, I think at the top there, a link to membership. And that link will then tell you how to go about becoming a member. It's $50 per person. Families, it's $75, so $25 additional to that first person, and that includes all your family members. And we usually go for a year, for 12 months, but while we're in lockdown, we're extending that to 18 months. So if you become a member while we are closed, while you can't get to the observatory site, to compensate for that, because you're not getting the full benefits of your membership, we're extending memberships to 18 months. Okay, I may have been a bit hopeful with this object because it's not exactly near where we were, and galaxies are very, very faint. So I can't see it in there, and I don't think I'm going to be able to pick it up just panning around. All right. In that case, what I might do is head back to where we were in that sky before and see if there are any galaxies in that area. Thank you, Janelle, for posting the link to my YouTube. I appreciate that. I'm a bit neglectful of that. I don't update it as much as I should. Most of my time goes into doing stuff for MBO. It gets sort of released on behalf of MBO, and most of my photography and astrophotography and social stuff that I do, I post on my Facebook profile. Before you send me a friend request, I'd be very flattered if you did, but I don't accept friend requests from people I haven't already met. However, you're welcome to go to my Facebook profile and follow my account. Following lets you see the things that I post that are marked with public accessibility, and the vast majority of my content, my posts that I make are public. So if you want to follow my Facebook, you can just go to facebook.com/Neil Creek, I believe will take you there, and you can follow me there. All right, let's see. What have we got here? Why not? I have no idea what it is, but it's got the galaxy icon, so let's have a look. Bit of lucky dip here. 6744. Center on that. I probably didn't need to search for it because I'd already clicked on it. And we'll slew to that. Oh, thank you, Janelle. You found that link as well. Alexis, Neil, you need to write some articles about your work, suggestions for setting oneself up with equipment, what to do and observe. Definitely could attract some income. Yeah, that would be great. The problem with that is finding the platform to sell them to. Blog posts, I did write professionally for a while, but I only got paid in exposure. And as any creative will tell you, there's a limit to how much worth exposure can be. Most blogging platforms don't make a lot of income. So a large audience lets you promote other things that you make. And I do make other things. I make video courses and ebooks. If you just search my name on Google, Neil Creek, you'll probably find some of those. So it's a bit of a challenge to make money from this sort of stuff, especially astrophotography. Selling prints is not really ideal because most people are happy to get their stuff from NASA. So NASA gives their photos away for free. So why would you pay for a photo when you can get it for free from NASA? So it is a bit of a challenge making an income from astrophotography. But it looks like we have ourselves a galaxy here. So this is going to be a little tricky to center because we are on 5-second frames. So let's just pick a couple of bright stars. So these two here are bright. So if I keep my eye on those, I'll need to move this one pretty much just off the bottom of the screen. So go back to my finding target preset. We'll lose the galaxy. Oh, we've still got the core there, that helps. And now let's pan down. Okay, we're on the 2 times speed, that's a bit slow. We'll go 3 times. Bit further. Okay, there we go. So galaxies are very faint and very small. And so far tonight, what I've been showing you here in this preview has been pretty consistently consistent with what you would typically see through a telescope. So an 8-inch Newtonian reflecting telescope, which is a very common one. If you were to look at this galaxy with that, you would see this. So not much. You just see the core really. It might look like a fuzzy blob rather than a point, which is the star. So the galaxy can be very, very difficult to see. But with the camera, even though it's going to be faint compared to the other objects we've looked at, a camera will let you see much, much better than you can with a telescope and an eyepiece. So we'll start our new sequence on that, and I'll just have a look at some questions. Lots of people are saying thank you. I'm very grateful that you've enjoyed this. Been very informal, nothing planned. So I'm glad it's worked out. I had a few troubles at the start, and I'm really pleased that those were resolved. Sometimes I've had nights where they don't get resolved at all, which is very frustrating. Okay, we're getting something here, but clearly 30 seconds is not enough for this object. So let's zoom into 100%, and we will watch that over a few minutes of time. So you can see definitely there is a sort of a shape around here, and you can see the core, and that's a little bit elongated. So it might be a barred spiral galaxy, but it's a bit early to tell yet. We'll need to get some more data on this so that we can boost the exposure levels without the noise taking over too much, and then we might be able to see what it is. Okay, Heidi says, looked me up on Facebook, couldn't find follow, only add as friend. Okay, maybe Facebook has changed things. On profiles, it used to be that under the cover photo, there was sort of a bar, and you'd have send friend request. And I think follow is next to that. Maybe it might be in a drop-down list under send friend request now. However, if you can't find follow anywhere, send me the friend request and I'll have to reject it. But I believe what Facebook does then is if you sent a friend request and it wasn't accepted, you still follow that person. Okay? So if you can't find the follow, then send the friend request, accept that I'll be rejecting the friend request, but then you'll be able to follow the posts. I believe that's how it works. Okay, we're starting to see a bit of detail here now. You can see there's maybe a spiral arm coming off this way, and maybe sort of a sort of ring there and a spiral coming off this way. You might just need a little bit more time. Pam Lynch asks, how far away is this galaxy? That's an excellent question. I will look it up and tell you. So let's go to the planetarium software, and it's NGC 6744. So I'm going to be doing something that I always get asked questions about. What app do you use? So let's go to the app I use to look it up. And what I use is one called Sky Safari Pro. It is a little bit more expensive than most apps. I think the base professional model is, I think, about $15 or something like that. But I've additionally purchased another, I think it's $20, and you can download a catalogue of several million stars. And that then gets added to the planetarium software, which I find useful because it helps me center targets that I'm looking for. So if I can see faint stars around the object I'm looking for, if it's a faint object like a galaxy, I can say, oh, I recognize those stars, so I know I'm in the right spot. So let's search for that galaxy, NGC 6744. If you missed it, I'll say again, the name is Sky Safari Pro. So NGC 6744. One second, just helping Heike out with something. Okay, it is in the constellation of Pavo, which I think is the Toucan. It is 30 million light years away. It is a spiral galaxy, and because it's so far south, it is always in our sky. It never sets. We can now sync to that, so that's good. That means we might even be able to go back to 47 Tucanae, which I really wanted to show you earlier. All right, so we are starting to get a bit more here. Let's see if we can improve the histogram a little bit. Oh yeah, that's starting to look okay. Come on, won't let me click. There we go. Yeah, there we go. That is definitely a spiral galaxy, isn't it? In fact, we may even be going further out here. You can see that there's sort of a glow all the way around it. And you can definitely see there's a spiral arm going around this way. And there's another little bit of one coming down there. And maybe one out this way as well. So definitely a spiral galaxy. And I would even say that could be a barred spiral galaxy. Barred spirals have this sort of lane of stars going across the core. And they often connect in with the arms. Let's zoom in a little bit further. Yeah, so you can see here, that is sort of connecting in with that arm. This, when we first looked at it in the preview settings, the search settings, all you could see was this core, and that's all you'd be able to see with an eyepiece through a small telescope. And with, what is it now, 5 minutes, 30 seconds of exposure, we've got all of this detail around here, which is fantastic. I mean, you can still see we've got noise and grain here. That's because I've pushed the exposure so much in the histogram. But with 6 minutes, we've managed to be able to drop the noise down enough that we can do that and we can see that detail. If we did this for 6 hours, then you'd be able to bring so much more out. You're probably hearing my phone going off like crazy. I think that's all the people following me on Facebook or other platforms and social media. Thank you very much for that. I hope that maybe I'll be able to chat with some of you folks on comments on my future posts. And I hope you enjoy my stream. Obviously, I post my own personal stuff there as well, not just astronomy. So I hope you don't find me too boring outside of this stuff. All right, so I think we'll stop there at 6:30. And Heike has just told me that another MBO member, Jackie, has joined in answering questions, which is wonderful. Thank you very much, Jackie. Jackie is our Director of Astronomy. She has the most incredible wealth of knowledge locked up in her head. If she can't answer your question, she can tell you where you can find the answer. So it's terrific that Jackie's here helping us out. So thank you very much for that, Jackie. What shall we do next? Well, since we've... I'll save this before I forget. Oh, we nearly finished. So we'll do one more frame. Since we've updated the pointing model again, I might try... I'm going to turn my phone down a bit. I might try 47 Tucanae again. It's been my my Moby Dick tonight. But I'm determined to find it. And we'll zoom back out to full size. Load the finding profile. Okay, so let's try 47 Tuck again. Okay, so telescope, slew 2. Dawn asks, can you post this on Facebook? The start tech issues is okay. I think that lives actually get archived on the page. So you'll be able to see this as it was streamed. So the same quality and everything, including all the technical stuff up at the beginning, which I suppose is educational, gives you an idea of what goes into this. So I have recorded it locally, which will be better quality, but even if that doesn't work out, then you should be able to see this at MBO Facebook page in an archive. So hopefully that's what you're looking for. Still no 47 Tucanae. Oh, this is starting to pee me off. All right, let's try another spiral search. Maybe it's just out of the frame. Cameron, you can do it, Captain Ahab. Ah, thank you. Shall I do my best Cornish accent? That's a bit Scottish, isn't it? A bit of a pirate thing. I should go. Hey, it was Ahab Cornish? Maybe he was English. I say Cornish because Cornish is kind of the pirate accent. My ex-father-in-law, or my ex-wife is Cornish. Still good friends, which is great. But her parents were born in Cornwall, so they've got a thick Cornish accent. And you know how they have Speak Like a Pirate Day? Well, my father-in-law is every day Speak Like a Pirate Day. Helen says the stuff ups was worth the wait. Thank you very much. I'm glad you think so. It has gone remarkably well after that. It's given me confidence that this will work well for a future stream. Just need to make sure things are working before I get people to cut to me. Jen says, it's become personal now. I'm sticking with you. You can do it. Thank you. The encouragement means a lot. I don't know why it's not finding it though. Maybe I'm... turn off those alerts. Maybe I am looking at the wrong object. Maybe the 47 Tucanae designation that I'm searching for is actually linked to something else in the database. So, yeah, I did say it may go over now. Joanna, you're right. When I'm on a good thing, I like doing it. I stick with it. So, what I might do, instead of that, I'm going to go to Google, search for 47 Tucanae, and look for its technical classification and see if that will get me closer. What is its alternative name? NGC 104. Let's see. NGC 104. Very close to the same object. Yeah, let's try that and see. Well, maybe I have a second camera on the telescope that I use for a technique called guiding. And what that does is it looks at a larger portion of the sky and it follows a star throughout my exposures and adjusts the telescope's tracking to make sure that star stays in the same spot the whole time. It's got a wider field of view, and usually I can use that to find things that are near my field of view, but I've been having trouble with it tonight. And I don't know why. See, it's saying 22 frames dropped. So I thought maybe I could give it a try and see if that could help me, but it's still having trouble. So, but no, don't want to capture a camera. How about I close camera, rescan, and then find it again. Will it work? No, it's still dropping frames. Well, that's weird. It finds the camera, but it's not getting any data from it. So it's not like the USB cable is unplugged. Ah, debayer. Maybe it's a mono camera, and that's why it's not working. Nope. Sorry about the technical terms, folks. If you don't understand what it means, it's just sort of jargon that you won't really be better off for knowing about. We could talk about that maybe in more detail in the future, but don't want to get too distracted tonight. All right. Well, Ahab didn't beat Moby Dick in the end, I guess, so looks like 47 Decane is going to beat me tonight. I wonder, is the other good globular cluster up at the moment? I don't think it is. It's called Omega Centauri, and it's very low on the horizon. No, that's below even the Southern Cross at the moment, so I definitely won't see that. All right, how about M4? That's another globular cluster, and that is in Scorpius, in the area we were at before. Let's try that. So we're slewing to that now. We should see the telescope reticle pop on there soon. Yeah, Cameron, you might have seen already the delay in the stream might not have caught up, but I did try Omega Centauri, and while it is above the technical horizon, it's below my horizon at the moment. So let's try this one. Ooh, that's looking dark. It might be below my horizon or right, like through the trees. Yeah, that's too low now. It's getting to the point of the year and the night where most of the interesting stuff, where the galaxy is setting below my local horizon. I sort of have trees and houses sort of coming across here, so I need to get higher up. So what have we got up here? One thing I will do the next time I do this is I will have a list of objects that I know will be above the horizon in the window that I'll be doing this. So I won't be searching for stuff, I can just go straight through to it. So this is, I can show you now here actually in the planetarium. You can see the Milky Way runs across here. And there's so many things in here, lots of different interesting objects. But as you look away from the Milky Way, we're not looking through all the stars. We're looking sort of out through the thin part of the Milky Way. So there's not nearly as much stuff. And what we can see is more often more galaxies, because the galaxies are, they're not obstructed by the stars in the Milky Way. They're spread out evenly throughout the universe, but the view of them is obstructed through the Milky Way. So looking up or down out of the Milky Way plane means you'll see more galaxies. All right. M30, what's that? It's a globular. All right, let's try that. Logs Harper, didn't he say earlier he has ADHD? Could be a long night. Guilty as charged. I'll probably keep going for a little while. I do get tired talking after a while. So I will see how long I last. I may only go for a little while longer, but I'm enjoying showing you stuff. I'm enjoying that you're enjoying it. And it's a great opportunity while the sky's clear, so I don't want to waste that. I censored the view on the object, but not the telescope. Okay, let's try that again. Slew to M30. We should see the telescope appear from down below, which is where I think we were looking for M4. From out here. All these M numbers, you might be wondering. An NGC, camera's gone again. These are catalogues, and they're different catalogues made by different people. The M stands for Messier, after Charles Messier, who was an early astronomer who hunted comets. He loved comets. Problem was, there wasn't a really great catalogue of all the things in the night sky, and he kept seeing these faint fuzzy objects that at first you'd think, oh, that's a comet, but it wasn't. And he got frustrated, so he made a list of them, of not comets. So because he was one of the earlier folks to make a catalogue, he catalogued most of the brighter objects because you see the brighter things first, and back in his day the telescopes weren't anywhere near as good as they are today. So he had this big catalogue of really big, bright, beautiful objects that he didn't want to look at. So it's a little bit ironic that we had this great catalogue of beautiful things that every amateur astronomer will eventually learn about and enjoy looking at because it was a bunch of things he didn't want. So it's small irony there. And speaking of small, looks like M30 is a small globular cluster. Although this is at our finding settings, so when I go into the imaging settings, we may pick up a lot more stars around that. So let's give that a go. We'll go into the live stack and wait for our first frame to come in. While we're doing that, I'll just see if there's any new questions. Thank you for tonight. I feel I have travelled much further than 5 kilometres up in the night sky. Vicariously, virtually. I'm glad that I've been able to take you out of your COVID bubble a little bit, even if it was only just in here. But there's a lot of worlds to explore in here, so I'm glad I could help. That is looking a bit better. Let's reset the stretch on that. And we'll zoom into 100 because it is relatively small, so we can bring it up in the frame a bit. We will want to bring the black up to just make the background a bit darker. And that colour is not right. That's better. But let's give it a bit longer because there's more stuff in there. I can see that there's going to be some more stars coming out with a few more exposures that I can get rid of the background and the contrast. Did you see just then the new exposure came through and it halved the noise? And actually that's an interesting point to make. You get diminishing returns on this. So the first 2 frames you add together, it kind of pretty much halves the noise because it averages the noise out. It's random between each frame. So 2 frames averaged out half the noise. But to get another halving of the noise, you need to get 4 frames. And to get another halving of the noise, you need to get 8. And you know how doubling works. Pretty quickly, that'll get up to ridiculously big numbers. And so you might be shooting for 100 hours to get as good an exposure that, half as much noise as you get after only 50 hours. So there is diminishing returns. Most of my exposures are between 2 and 6 hours. But you really do get results from going longer. I have seen 100+ hour exposures, and the stuff that the really good photo processors can extract from that is just amazing. Okay, so apparently people are asking how much longer. So maybe it'll be time to start winding it down. Let's see, I've done nebulae, galaxy, open cluster, globular cluster, planets. We've kind of done a bit of everything, haven't we? So I might let this one go to say 8 frames. And then I'm going to see if one object that I really like has risen yet. And if it has, we'll get a shot of that. And then we'll finish for the night. And if it hasn't, we'll finish there. But one of my favourite objects in the sky is called the Tarantula Nebula. I got distracted because I was reading your comments. The Tarantula Nebula, and it is the most amazing thing. It is one of the biggest and brightest nebulae that we know, but it's not. When you look at it in a telescope, you think, is that all? Because if it's the biggest and brightest, shouldn't it be bigger and brighter than what I can see? Well, the thing is, it's in another galaxy, and we can still see it as a nebula that competes with the ones in our own galaxy. So the famous Orion Nebula, you may have heard of that one before. It's in the Sword of Orion, or the handle of the saucepan. That's about 1,600 light years away. It's a bright object in a dark sky. You can sort of see it with your naked eye, just as a little fuzzy patch in the handle of the saucepan. The Tarantula Nebula, that's 160,000 light years away. 100 times as far as the Orion Nebula. And it looks almost as bright. So if that nebula was as close as the Orion Nebula, it would fill up a quarter of the night sky, and it would shine as brightly as the full moon. So that would be a hell of a sight to see, but I'm kind of glad we don't have that, because if that was as bright as the full moon, it was in our night sky, we wouldn't be able to see any other nebulae. So I like having a variety. Maybe one day we'll be able to teleport ourselves to other galaxies. Okay, that's starting to look quite nice. Yeah, look at that. That's lovely. But we'll stop that one there. We'll save it. Clear it, and let's see if the Tarantula is up. So let's give it a go. NGC 2070 telescope SLU 2. It might be a close call. I think this one might just be below the trees, but there is sort of a gap in my horizon out that direction, so it's worth a try. Here we go. Alright, let's see how it looks when it's finished slewing. Just wait for it to settle down. It is going halfway across the sky, so it may not be in the right spot. And we'll zoom out to auto. Well, we have stars at least, so that area is above the horizon. Let's try doing a quick spiral search and see if that brings it up. Heike has relayed a request to see the jewel box. Unfortunately, that is well and truly now below my horizon. It is an object that, with a perfect horizon, is visible all year, but the Southern Cross is quite low in the sky right now, and that's right near the jewel box, or should I say the jewel box is right near the Southern Cross. And it's low in the south, and my south horizon is no good. So unfortunately, the jewel box is not visible for me at this time of the year. I really need to get my guide scope fixed so that I can use its wider field of view to find these objects, because it's much easier to look for something with a wide field of view if it's bright enough to be seen, which the Tarantula is. So we'll just do this for a couple of minutes and see if we have any luck. I want to find it because it's amazing, and it should be visible. If these stars are visible, it's in the general area. But I don't want you guys to just sitting here watching streaks going across your screen. It's kind of boring. There really is no other way to search for it, unfortunately. Oh, you know what? There is one other way. I've been using this this software that is good for live streaming. I mentioned that earlier, but not so good for longer exposures. or finding things. However, other software that I use is. So if I use the software that I take photos with the longer exposures for, I can center it with that and then hop back to the live view stuff. So this is a bit of a delay. It might take a little bit longer, but probably not longer than searching for it with Spiral Search. And if you can still hang around a little bit longer, I believe you'll agree that it is worth it because it's an absolutely amazing object. I'm just closing off all the stuff that I had from previous sessions in this. It automatically reloads them. So what I'll do now is I'll show you the process that I go through for finding an object when I'm doing a long exposure sequence. So this has got a wonderful little wizard in here where I can type in the object. It'll find it in a catalog and load a preview image of it. So this is not my photo, this is from a catalog. I can drag a box, and this box is the same size as the field of view of my camera on the night sky. So I can drag this box around and say, this is the composition I want. Then I create a sequence, which is what I use to take the photos with, sort of the list of photos that it takes. And I can center it from that. Why isn't it allowing me to slew? Okay, I'll center it. Because the telescope isn't connected, I need to disconnect it from the other software first. I mean, I may not need to do that, but things can get temperamental when they're fighting over control over the telescope, and I'll close that software just to make sure. So I connect the telescope. I'm not going to worry about the focuser because we're already focused. I'm not going to use the filter wheel because we're using color camera, not the black and white camera, so no filters. Connect the camera. I don't know why it's warning me about that driver. I might need to have to update my driver later on, but it was working in here earlier tonight. So now, will it let me slew to it? I'll try centering. It failed. Okay, let's try slewing at least. It's parked? Let me see. No, it's not. All right, well, let's see what it does. So is it moving? Yes, it is. All right. Now this isn't linked with the planetarium software at the moment, so I can't see in that sort of graphical view of the night sky where the telescope's pointing. I kind of have to trust that it's moving to the right spot. And it seems like it's finished centering. So I'm just going to get a test shot in here. And no. Okay. Maybe I should do the centering. And it complained last time. Why is it complaining about the auto centering failing? Okay, I have to get this sorted before I can do any more imaging. But what centering does versus slewing is it uses a technique called plate solving, where it takes a photo of the night sky, looks at the stars, compares those stars with the catalogue so it can find out what stars it's looking at, thereby calculating its coordinates and seeing how far off where it's supposed to be, and then moving to the right spot. So the telescope actually knows where it is. I don't have to keep telling it. But I haven't seen this error before, so I don't know exactly why it's doing that, which is a little frustrating. Well, more than a little frustrating. All right, I'm going to need to do some proper problem solving with this to find out what's going on. So I am going to call the stream a close tonight. So thank you so much, everyone who came along to this impromptu test. There were some technical issues, but I guess that's the point of having a test. However, we still managed to have a nice little tour of some interesting objects in the night sky. You all seem to enjoy yourselves, which I'm thrilled about. And hopefully we'll be able to do more of this in the future, either more impromptu stuff or as part of our regular Night at the Observatory stream. While I've got you here and you're still watching, I want to remind you all that Mount Burnett Observatory is a volunteer-run community observatory. We exist on the support of our members and the public. So if you like what you see, if you think we look cool, and you're interested in astronomy, please consider becoming a member. You can go to our website at mbo.org.au and follow the link to membership there. And you will find lots of amazing people who have similar interests to you to talk to share your ideas. And when we get access back to the observatory again, you'll be able to look through our telescopes, have us help you out with your equipment, and learn astrophotography from me if I'm there and have the time, which I usually am. Also, keep an eye on our Facebook page. You are probably all members already of the Facebook page, so thank you. But we'll be doing another live stream probably in about 3 weeks from now. Not certain for sure. We haven't set a date yet. But after the success of the last one, which was huge, we would love to do it again. So thank you so much for watching. I really appreciate the support and from you coming along. And I'm glad you all enjoyed yourselves tonight. So I look forward to seeing you in the future. Keep watching the skies. Now, how do I end this? There we go.